In a set of independent trials, a discrete random variable j takes on the following values. Your values might be different, but if you're going off the example it's from the book, it'll be the same. So this is what we're going to look at. We want to obtain an estimate and plot the probability mass function of this random variable, and then we want to calculate the mean EJ and the variance var j. So to start this off, what we're going to do is notice how for our discrete random variables, we are given a couple different values, a few different values. So let's look at how many ones we have. So with our ones, we have 1, 2, 3, 4, 5. So we have 5. So that means we're going to have 5 out of a total of 15 ones. Now let's look at our 6s. So 6s, we have 1, 2, 3, 4, 5, 6. So we have 6 out of 15. And just by counting them up, if we have 11 here, 5, 6, that means we're just going to have a 4 over 15 for our 9s, and we can go through and mark each of them. So those are our values there. Now let's graph this, right? We want to obtain and estimate a plot of this probability mass function. So we can draw something out like this, move it right here. We are going to have, let's say, j right here, right? Random variables j, make it uppercase j, and then we're going to go from f of j, we have j inside of here, and let's plot these. So we know our j values are given to us as 1, and this is not drawn to scale by any means, but 1, we'll have 6, and then we'll just have 9 over here. And so these values are going to be from here. So I'll just draw like a bidirectional arrow. And if we have 5 to 15, and let's mark off some points. So our y-axis will be more drawn to scale. I'll try to make it more drawn to scale. We have 5 here, and we'll have, or let's do like 2, 4, 6, and we'll just stop at 8. So for 5 over 15, we'll just say that the 5 goes right here. 5 over 15, this is where it's going to be for our 1. For our 6s, we are going to go 6 over 15. So it's going to go a little bit higher. 6 over 15 right here. And lastly, we have a 4 over 15. So that one's going to be the lowest. Probably a little bit higher than that, though. Somewhere around like right here. And this is our 4 over 15. So those are going to be our obtaining and estimating and plotting the probability mass function. Remember, probability mass function is also known as PMF of this random variable. So this is our PMF graph. Now let's look at part B. Part B, we want to calculate the mean EJ. We'll do this first. So we have E, and it's of J. And what we're doing here is we are going to put our values, so our j values, with the probability of j. And so, and we're going to want to add these together. It's like a summation. Summation is just going to be this little guy right here. So this is going to be equal to, we have, if we start off with our 1 first, we have 1, 15 over, or 5 over 15, plus 6, and then we have 6 over 15, plus we have 9 with 4 over 15. So if we put this into a calculator, we'll get a value somewhere around 5.133, just like that. So 5.133, and then we are going to have our EJ squared. And so now we will calculate the variance. And so the var of our j is going to be something like this. It's going to be equal to our EJ squared minus our EJ, and to make things equal, we're going to square this as well. So this is going to be squared. So to calculate for this, we are just going to say we have our EJ squared, and it's equal to, it's going to be the same thing that we have up here, essentially. So we can copy this and then just paste it right here. So the only difference here, though, is that we are going to be squaring our j values. So that's pretty simple. It's going to give us a 36.3. So that means inside of here, when we plug everything in, we're essentially going to have 36.3 minus 5.133 squared. And this is going to give us a value of about 9.95. So this is the variance, this is our mean, and this is our PMF plot.